Today we are going to evaluate this limit, and the limit is limit x approaches infinity of x over square root of x square plus 1. And so we have to find the value which this function approaches when x is a very large positive number or gets very huge. So uh, in the numerator we have x. So x is a very large positive number. It is getting bigger and bigger. So in the numerator we'll have infinity over, in the denominator we have square root of x square plus 1. So x is approaching infinity, meaning it is a very large positive number. So x square will be an even larger positive number. Adding 1 to that makes no difference. This will remain infinity. And when you take the square root of a very large positive number, it is still a very large positive number. So we have this infinity over infinity form, which is an indeterminate form. Uh, this is not equal to any value. So we need to get rid of this indeterminate form to find this limit. And normally, uh, when the variable is approaching infinity and we have to find the limit for uh, a fraction which involves variables, normally what we do is we divide the numerator and denominator by the highest power of the variable present in that expression. So here we have what the the highest power of variable which is present in this expression is basically 2 x square. So normally what we would have done is we would have divided this fraction by x square. And why do we do that? We do that because the terms get cancel out, and uh, we are mostly left with fractions which have uh, the variable in the denominator, and normally those terms approach 0 when variable becomes huge. So but here it's not possible. And why is uh, that strategy not fruitful here? Because uh, if we divide this given function by x square, we have x over x square over square root of x square plus 1 over x square. So uh, we get some cancellation in the numerator, but in the denominator the problem lies with this square root, because you can't write this as x square over x square plus 1 over x square. You can't write it that way because there is a square root over x square plus 1. So this square root is basically the problem. So if you want to get rid of this square root, or if you want to divide x square and 1 separately by this x square, you must divide by both the numerator and denominator by square root x square, because if you do it this way, this is not helping you. So I have divided the given fraction by square root of x square, and you'll see that how does that help us. So in the numerator I have divided by square root of x square, and same in the denominator. So this becomes x over square root of x square divided by square root of x square plus 1 over square root x square. So we can do that because this doesn't change our fraction. So in the numerator, square and square root, they cancel out because square root is 1 by 2 in power form. And so we are left with basically x over x in the numerator, and in the denominator we have two square roots being divided. So whenever we have two expressions and those expressions involve square roots and they are being divided, we can use the property of square roots and write that as single square root of the quotient of those expressions. So I have written this as limit x approaches infinity, x over x over square root of x square plus 1 over x square. So I've combined the square roots by using this property. So in the numerator, x and x cancel out, and in the denominator, now you see that what dividing by square root of x square has done for us. Now we have an expression which is inside a big square root and a single square root, and we can separate this or distribute this on this common denominator. So we can write this as x square over x square plus 1 over x square. So this becomes limit x approaches infinity of 1 over square root of x square over x square plus 1 over x square. You can do this because combining these two terms will give you this. So x square and x square cancel out, so you are left with 1 over square root of 1 plus 1 over x square. And remember, x is a very large positive number, it is approaching infinity. So when x is a very large positive number, x square is even larger positive number. So this number in the denominator, it is huge, it is very big positive number. So when you divide 1 by a very big positive number, the fraction approaches 0. It makes sense because when you divide a thing into many pieces, the individual pieces become small. So I've written here that as x grows large, x square grows even larger, and 1 over x square gets really small and approaches 0. So let's assume that x is 100. So that means that x square will be 10,000. So 1 over 10,000 will be a very small positive number. It will be 0.0001. So this term will approach 0, and we are left with 1 over square root of 1 plus 0, and 1 plus 0 is simply 1. So 1 over square root of 1 is equal to 1 over 1, and 1 over 1 is simply 1. So the limit is just 1.